Okay, let's go ahead and get started here. Today is 4.3 congruent triangles. Our I can statement today is I can name and use corresponding parts of congruent polygons. Some vocabulary here we're going to talk about. So first off, congruent here. I think we all know what congruent is. That just means when we have two angles or two sides that are equal to each other. Congruent polygons here. This is exactly what it sounds like. These are two polygons that are in fact congruent. And anytime we have congruent polygons, we're going to have what we call here corresponding parts. So corresponding parts are essentially just sides of triangles here that correspond to each other. So let's take a look here. We kind of got some information here that goes along with that. So here we are given the fact that ABC is in fact congruent to HJK. So if these two things are congruent, what we can say about this is that all of their corresponding angles and all of their corresponding sides will be congruent. So how do we know which angles correspond or which sides correspond? Well, in our congruent statement here, that's what this is. That's when we say, hey, triangle so-and-so is congruent to triangle so-and-so. We actually will match up our letters perfectly to where the corresponding angles, the corresponding sides, match up. So for example here, if in triangle ABC here, the A comes first, and in triangle HJK, the H comes first, well, guess what? That tells us that A must be congruent to H. So as you can see here, when it's listed out, yes, that is actually the case. Likewise, B, since B is the second letter and J is the second letter, those two angles, angle B and angle J, must also be congruent. So B and J. Lastly there, C and K. Those were the last three, or the third letter there. So C and K would be congruent. Now, you're probably asking, how does this work with sides, though? Well, if we wanted to look at the corresponding sides, what we would do is we would just look at the two letters. So A and B here are our first two letters. Well, guess what? A and B are going to be congruent to the first two letters of triangle HJK, so H and J. So as you can see, corresponding sides here, AB congruent to HJ. Likewise, if we take our next two, B and C, J and K, the second two letters here, BC, is congruent to JK. And finally here at the end, if we take our first letter and our third letter, so A and C, and we take our first letter and our third letter, HK, well, guess what? Those would also be congruent. So everything here, as far as corresponding sides here, has to do with our congruent statement. So our congruent statement means a lot to us. It tells us a lot of information. The only thing I want to tell you here is notice how our one loop mark here is going to be congruent to our one loop mark, as well as our two, A congruent to angle H. Well, guess what? Both of them have two loop marks on them, which means those are congruent. So pay attention here to all the things going on in this triangle. As you can see, this is how we are going to label that the angles are congruent to each other. So make sure if we are saying that angle A and angle H are congruent, they have to have the same amount of loop marks. Likewise, if we're marking our sides here, AC and HK, well, they have to have the same amount of hash marks. So AC has 3, HK has 3. All right, so it says here, show that the polygons are congruent by identifying all of the congruent corresponding parts, then write a congruent statement. So what we need to do here is we need to come up with all of the angles that are congruent. We need to show all of the sides that are congruent. And then we need to write a congruent statement. So if we were to do this here, if we started with angles here, I'm just going to start with angle A. Looks like these are literally right next to each other. They're not flipped around or anything. They are perfectly right next to each other. So we're going to be able to kind of do this pretty quickly. We're kind of going to be able to just go right down the line. So if we start here with angle A, we can say here that angle A is congruent to angle R, because those are in the same position. Same thing goes for angle B. We'll say angle B is congruent to angle T. And we're just going to keep going on this train. Now, we're not always going to be able to say this because sometimes we're going to get some polygons that are a little flipped around. So some of them might not be right next to each other the way this one is, which are going to make things just a little bit more difficult. But since this is our first one here, this is a pretty straightforward one where we can kind of just go through this and write these out. Now, same thing goes for sides here. So I'm going to start here with AB. And we're going to say here AB is congruent to RT, right? Since both of those are the segment that goes down and to the right there. Now we're just going to keep on rolling with our segments here. So BC is going to be congruent to TP. Then we're going to say here CD. Well, CD is going to be congruent to SP or PS. It does not really matter which way you put it. DE here is going to be congruent to SQ. Okay, so some of you are probably saying, well, you said SP instead of PS. Well, SP and PS are actually the same exact segment. That's by the reflexive property. So we'll talk a little bit about that later on. Here, congruent statement. So if we wanted this congruent statement here, the most important part is that we make sure every corresponding angle inside match up. So by writing out the angles in the sides here, we actually did ourselves a big favor because we can use these angles here to just go directly in order. So we can just run straight down the line here. We can say A, B, C, D, E is congruent to R, T, P, S, Q. To R, T, P, S, Q. Okay, so that's our first example there. That's what that looks like. Normally, if these were, a normal shape, let's say if they were a triangle, we would put a triangle in front of both of these. But since this is just kind of an irregular polygon, we are not going to put anything out in front. Okay, moving on here. So it says the support beams on the fence form congruent triangles in the figure. Triangle ABC is congruent to triangle DEF. Which of the following congruent statement correctly identifies the corresponding angles or sides? Okay, so if we know that ABC is congruent to DEF, well, that means that tells us that the first letter here, angle A, is going to be congruent to the first letter here, angle D. So if that is the case here, we are going to use that to help us figure this out here. I know A and C, this one right here, that's not going to be the answer because we don't need to change the congruence statement. We just need to show what it means to be corresponding. So BAC, well, if we did BAC, that would be the middle, the first, and the third. So we would need this to be the middle, the first, and the third. So this, if we had BAC, would have to be EDF, not DFE. So we know that those two are going to be incorrect. Now let's take a look here. BC congruent to DE. Well, BC is the second and the third letter in this. DE would be the first and the second. So this is not going to be the answer here. So our answer here must be AC. AC is the first and the third. DF is the first and the third. So we know here our answer would be AC is congruent to DF. Okay, moving on here. It says in the diagram, triangle ITP is congruent to triangle NGO. Find the values of X and Y. So ITP, NGO, we got to find the values here of X and Y. So let's go ahead and find an X here. It looks like X would be right at NG. So NG are our first two letters here. So if we know that these are congruent, what we're going to do is we're going to take the segment or the angle and we're going to set it equal to the segment or angle that it corresponds to. So NG would be the first two here, X minus 2Y. And we could say here that's going to be equal to the first two of our other triangle here, IT. So IT looks like it is 7.5. All right, so we've got one equation set up, but it looks like this has an X and a Y in it, so we're not able to solve for that just yet. Not able to solve for that just yet. So let's go ahead and try to solve for Y here. Looks like Y is 6Y minus 14, and that is at angle O, which is the third letter of our triangle here. So that is going to be congruent to the third letter of the first triangle, angle P. So what we're going to do is we're going to take 6y minus 14. We're going to set that equal to angle P, which is 40. So we get 6y here. Minus 14 is equal to 40. Let's go ahead and solve this for y. So we're going to add a 14 to both sides. This is going to be 6y equals 54. And then we're going to divide both sides here by 6. And we are going to get y is equal to 9. Okay, y is equal to 9. So there's one of our answers. We can actually plug that answer in for our y right here. So I'm going to leave this in red because that's what we use to solve for y. I'll put everything else here in black. So x minus 2 times 9 is equal to 7.5. So this is going to be x minus 18 equals 7.5. We're going to add an 18 to both sides here. We are going to get x equals 25.5. All right. So right here it says in the diagram, triangle FHJ is congruent to triangle HFG. Find the values of x and y. So if we're going to do this here, what we need to do is we need to take a look at our letters. So I want you to go ahead and try to pause this and do this one on your own. And when you come back, we're going to do this together. Okay. So if we are looking at x, x looks like it is an angle F. Okay. And that would be angle F of FGH. So FGH would be the second triangle here. So we're looking at this second letter. All right. Now the second letter is going to be congruent to the second letter. So F is going to be congruent to H. H is down here. So H appears to be 35. So if we wanted to solve for x here, we could say that 6x plus 8 was equal to 35. I apologize for my pen. I'm making mistakes. Subtract an 8 here from both sides. This is going to be 6x equals 27. Divide both sides by 6. This is going to be x equals 4.5. So there's x. Let's go ahead and solve for y now. Y looks like it is FJ, and that would be of the triangle FHJ. So FJ would be the first letter and the third letter. So we're going to be able to say here that FJ is congruent to the first letter and the third letter in our other triangle, HG. So HG appears to be over here. And HG appears to be 2.5. So we're going to say here 2y minus 3 is equal to 2.5. So here we're going to add a 3 and then divide both sides by 2. So y here is going to equal 2.75. I don't know why everything's so laggy, but it is. All right, moving on. We got the third angle theorem here. Okay, the third angle theorem says that if two angles of one triangle are congruent to two angles of a second triangle, then the third angle of the triangles are congruent. So, as you can see here, angle C congruent to angle K. Why? Because they both have one loop mark. Likewise, angle B congruent to angle J because they both have two. So since these both have two congruent angles, that means that the third angle, angle A, will be congruent to the third angle, angle L. Okay, so we would put 3 loop marks there to show that. So just know, anytime we have two angles that are congruent, that means automatically that the third angle is congruent.